This next problem is just a multiple choice question asking you what does the cosine of theta represent for the triangle shown. Well, theta is the angle of reference. So from here we need to label our sides. So the side furthest away from that is still opposite. And the side not touching the right angle is still a hypotenuse. And that leaves us with adjacent for this side. Alright, well cosine, if you think about the saying like so ka toa, so that's the a over h. In this case, all we do is replace a and h with what they are. So instead of a, we're going to write t. You can see the adjacent right there is t. And the hypotenuse is g. So t over g is the correct answer, which is right there. It's choice D. Alright, with the next one, we're going to use an application. It says as a plane takes off, it ascends at a 20-degree angle of elevation from the airport. If the plane has been traveling at an average of 290 feet per second and continues to ascend at the same angle, then how high is the plane after 10 seconds? Well, it's kind of a right triangle. You can see it kind of built into this problem. There's the angle of reference. So the side furthest away over here is opposite, which is the height of the plane, how high the plane is. And I want to find that. There's the right angle. So the side not touching the right angle is hypotenuse, which leaves adjacent here. So step 1's covered, I labeled. So step 2, which side do we have? Okay, we have the hypotenuse. And which side do we want? We want to know how high the plane is up in the air, so we want opposite. So the trig ratio that relates h to o, if you remember, go through, look at the notes if you need to, but that's sine. So this tells me right here that I should use sine. And then just like always, we set up the statement. So in this case, it'll be sine of the given angle, which is 20 degrees, is equal to opposite over hypotenuse, because that's sine's relationship. It's always over h. O we don't know, we're trying to find it, so we'll call that x. And hypotenuse we know is 2900. And then just like we've done several times prior, you put the sine of 20 over 1 and cross multiply. So this will be x times 1, which is x, is equal to sine, or 2900 times sine of 20. So then use our calculator. 2900 times sine of 20. Guess I have to pull the whole screen there, so it looks like 992 feet approximately. Here, let's look at the next one. All right, so it says a person noted that the angle of elevation to the top of a silo was 65 degrees at a distance of 9 feet from the silo. Using the diagram, approximate the height of the silo. All right, so again, there's another built-in right triangle, so we know that this is the angle of reference. So the side furthest away is opposite. That's the one we're interested in because we want to find that how high that is. And then the side not touching the right angle would be hypotenuse. And that leaves the third side to be adjacent. So again, we ask ourselves, which side do we have a measurement for? We have a measurement for, if you look carefully, we know the adjacent is 9. So we have adjacent. And which side are we interested in finding? We want to know how tall it is, so that's opposite. And if you go through your trig ratios, which one relates A to O? That's the TOA part, and this says to use tangent. So then we can set up our statement. Tangent of the given angle, 70, is equal to opposite over adjacent. All right, in this case, opposite's the unknown, so we're going to call that x. That's what we're trying to find. And adjacent we know is 9. So, as we've done so many times before, put tan of 70 over 1 and cross multiply. So x times 1 is just x. And tan of 70 times 9, I'm going to write 9 times tan of 70. And then just put that in the calculator. And so the silo is approximately 25 feet tall, which is probably about 2.5 stories. That sounds about right. So I'll round to the nearest foot, 25 feet. All right, it says a kid is flying a kite and has reeled out the entire line of 150 feet of string showing. If the angle of elevation of the string is 65 degrees, then which expression gives the vertical height of the kite? So they didn't really say which expression, we're going to find it. All right, so again, our angle of reference is 65 right here. The side furthest away from that's opposite. You can kind of see the right angles right here, so the side not touching the right angle is called hypotenuse, and that leaves this side to be adjacent. All right, so again, ask yourself, which side do you have the measurement for? We have, in this case, the hypotenuse, and we want to find out how high the flag, or how high the kite is, which is right there, the question mark, so it's opposite. And so look for the trig ratio that relates h to o. That's the very first one, the so. So this says use sine, and then set up the statement. So sine of the given angle, 65, is equal to opposite over hypotenuse. And in this case, we know the hypotenuse is 150. And I'm looking for the opposite, so I'm going to call that x. And then put sine of 65 over 1. Cross multiply and solve. So x times 1 is x. And then sine of 65 times 150, I'm going to write 150 first, times sine of 65. So it's saying the kite is approximately 136 feet in the air. Alright, I hope this was helpful. I'm going to stop here and start the next video in just a moment.